Okay, guys, good evening, everyone. Hope you guys are all doing fantastic. So today we'll be talking about one of the most important topics, from the exam perspective, especially, and even real life. It's called auto scaling. So, as the name says, it's going to scale your EC2 instances automatically. Essentially, that's what it means. And we talked about the concepts of availability and scalability before, right? So let's say that you have a web application running on a bunch of web servers, and you found out that each web server can scale or can take, 100 concurrent requests. So let's say you have 2 web servers out there. So that means you can take 200 concurrent requests. So what happens when a more load comes? So if your load increases, these 2 EC2 instances will not be able to take the load. So essentially, you will see a user's performance degradation. Or instances, they will go probably with out of memory errors or CPU spikes, you go all over. So how can we scale this? Well, you can manually scale it. So you can manually go ahead and scale from 2 instances, 2 EC2s to add 8 more EC2 instances and add it to the application load balancer. So you guys are all working in your organization. If you look at it, definitely there is a pattern that you may be observing. In all the non-cloud environments, even in the cloud, if you don't architect well, you're not taking advantage of it. But in the non-cloud environment, so your systems, your infrastructure is designed with certain load in mind. Let's say you have 15 web servers. So somehow through your past experience, by observing the user pattern and load profile, you found out that probably 15 web servers are good. But are they really utilized all the time? How many web servers are really utilized? Or as a matter of fact, how many web servers, database servers, application servers, how many of them are really utilized? Let's talk about EC2 instances here. So I'm talking about web servers and application servers. How many of them are really utilized? Either you are undercapacitized or overcapacitized. So on a day like Black Friday, I'm sure you are undercapacitized. Your 15 web servers will not work, for all your electronic websites and all your consumer-centric websites, right? So, but if you go scale them to 100 EC2 instances, you'll be overcapacitized for 99% of the times or 95% of the times. You understand what I'm saying here? So based on the load profile, either you are underutilized or overutilized. Can't I dynamically scale them based on my load demands? That is actually auto scaling. Yes, you will be able to do that. So you will be able to auto scale it. Okay, so you don't have to guess your capacity needs anymore. Identify the metrics. You just say that each web server can take up to 100 requests. So it cannot handle more than 100. So let's say you are getting 200 concurrent requests, and then if you have 2 instances, 2 EC2 instances are enough. But if you get 1,000 concurrent requests, then you need 10. So you want to be able to automatically scale it. How can we do that? That is the topic today. So auto scaling ensures the correct number of EC2 instances for your application load. so that you don't have to undercapacitize or overcapacitize. It just maintains the number of instances. It's called the desired capacity. This is the most fundamental thing. Let's say if you know that your load is so static, how many times your load will be static? It will not be. But if your use case is so in such a way that you know that you are good with 5 web servers or 10 web servers, all the time you need to keep running 5 or 10. Yes, auto scaling will make sure that you have that desired capacity. If you say that I need 10 EC2 instances to run my website all the time, if something goes wrong with one of the EC2 instances, for some reason it is stopped, then auto scaling will automatically identify that EC2 instance is stopped, and it will terminate it and add a new EC2 instance to the pool. That's the beauty. And if you really leave it to the auto scaling, it will automatically distribute these EC2 instances across all the availability zones also. So it increases your availability also. That's the beauty. So it scales automatically to your needs. So there is something called minimum capacity and maximum capacity. There are three words that you need to know here. One is desired capacity. That's your optimal number. So if you don't want to use a dynamic scaling, if you want to say that, I need 3 EC2 instances all the time, then auto scaling will make sure that you have 3 EC2 instances. If one of them is stopped, then it will automatically terminate it and create a brand new one and add it to the pool. It will do it. But you can set up your automatic scaling also, auto scaling, using something called scaling policies. We'll take a look at it. So it will scale between your minimum and maximum. So based on your preferences, you can say that I need 2 instances, minimum of 2 instances all the time. But no matter what my metric says, please do not exceed 100 instances or 10 instances. Then it will swing between 2 instances and 10 instances between that. And then it will scale out and scale in based on triggers. So what exactly is scale out? Well, scaling out meaning adding new EC2 instances to the pool. Scaling in meaning terminating or deleting the instances, terminating the EC2 instances essentially from the pool based on the triggers. So you use your CloudWatch. That's why I covered CloudWatch in the previous class. So you use your CloudWatch triggers. You can create a CloudWatch alarm that, when my EC2 instances CPU utilization goes above 80%, then I need to add a new EC2 instance. You can definitely do that. Or if number of requests that it's taking is more than 20, then add one more. So that's the scenario where you're increasing of the load. I mean, both of them are actually. So you can do an average CPU utilization or your network in, network out. So different varieties are there. But these are all the metrics that can trigger scale out, meaning adding instances, scale in, meaning terminating instances. So, and also it automatically scales across all the availability zones. So if you select during the creation of auto scaling group, okay, group is nothing but a logical entity that's a set of EC2 instances. That's all it is. So if you say that I want my EC2 instances to be distributed across all the availability zones, it makes sure that it's properly distributed. So you're not putting all the eggs in a single basket. So there is a concept called auto scaling group. So you will create a logical group of EC2 instances. That's what the group means. So in the auto scaling group, when you create it, essentially you need 3 attributes. One is, what's the minimum size for your auto scaling group? Let's say you're talking about web servers from my website, right? So what's the minimum size that you want to maintain? What's the desired capacity? So if you specify the desired capacity in a static scaling mode, you are saying that make sure I have 5 EC2 instances all the time. That's your desired capacity. But if you want to go from dynamic scaling, then you will swing between minimum and maximum. So it will automatically scale out as needed. Does that make sense? So you can specify that I need 2 EC2 instances all the time, meaning even if you do not have any CloudWatch alarms triggered, meaning even if you do not have any load, I need 2 web servers running all the time. Makes sense, right? Because I don't want my site to be down in case one of the availability zone is down. So you can specify your minimum and then maximum. No matter how many requests I get, okay, I want to look at my cost also, pricing. So no matter what, I do not want you to scale out more than, let's say, 10 instances. Then it adjusts between 2 and 10. Does that make sense, guys? So in auto scaling group, so these are the components. Let's take a look at it. The first one is, it's called group itself. So auto scaling group. Group is a logical unit of EC2 instances. Let's say you have one group for your web servers, you have another group for your application servers, etc. And there is another concept called configuration template. Okay. So this configuration templates, they call it launch configuration or launch template, essentially. So what it means is, it is a template. So how does EC2 auto scaling, how does it know what kind of EC2 instances it should provision? Should it be a T2 micro or C4 extra large? How does it know? In your Amazon machine image, AMI, you only have the data. You only have the EBS volumes that are attached to it, right? You don't have what kind of instance type are you using, what key pair are you using, what security group should this, once I create this EC2 instance, okay, what security group should I attach this one? So all of that, you create a simple template, and then you give the template to your auto scaling group, and you create a new auto scaling group with your appropriate scaling policies, and that's it. It will maintain that. So when you create your auto scaling group, you will specify your scaling options. So you can say that statically, hey, I want to maintain 5 EC2 instances all the time. Make sure I have 5 all the time. That's your desired capacity. Your min and max doesn't matter at the time. I know your desired must be in between min and max, but in the most basic scenario, you can say your min 5, max 5, desired 5. Keep all of them same, then it will make sure you have 5 EC2 instances all the time. So what it means is, your web server, you found out that your web server needs 5 EC2 instances, and you put your simple scaling option, static scaling option. You gave your minimum, maximum, desired all 5, and it makes sure you always have 5 instances. And what you do is go ahead and you just give itself like a couple of minutes, and you will see that auto scaling group realizes there are 0 instances, there are 0 EC2 instances that are created and maintained by your auto scaling group. It will go ahead and provision new EC2 instances automatically. And you will also see tonight that when a new EC2 instances are provisioned, it will automatically add them to your target group of your application load balancer also. So that means when auto scaling group provisions new EC2 instances, it will add to the application load balancer. So that application load balancer continuously can start sending the new request to these newly provisioned EC2 instances. As your demand grows, it will scale out as demand decreases, it will scale in, meaning it will terminate the instances. So there is something called scaling options. This is where you will specify how many EC2 instances you want to maintain, or you want to say this, I have more complicated scaling policies. I want to swing between 2 and 10 instances. Okay, and I have like a step scaling policies. I want you to adjust it. If the average CPU across all the instances in my group crosses 40%, add a couple of instances. Once it goes between 40 and 60, add a couple of instances. After it goes above 60%, add a couple more. From between 60 and 80. From 80 to 100, add 5 more. You can go really, you can create complex scaling policies. So scaling options, so it maintain current instance levels at all times. You can keep the minimum, desired, and maximum as same. This is a simple option here, guys. It's if you really want to maintain current instance level at all times, meaning you are kind of manually saying that my web server needs 5 instances, keep them all the time. Or if you want to scale manually, you don't need to, it shouldn't be called auto scaling in that case. So essentially you are going and messing with the minimum and desired and maximum so that your auto scaling group will adjust the capacity. The other one is scheduled scaling. Maybe you know your capacity needs. So in a simplistic example, I wanted to say, let's say your QA environment. Let's say you are using 90 EC2 instances for production, and QA you are using 90 EC2 instances also during QA SLAs. Your QA SLA is most likely not the same as production SLAs. Production SLA you'll have 24/7, and QA SLAs will be typically, let's say 7 a.m. to 7 p.m. So at 7 p.m. you can put a scheduled scaling saying that scale down or scale in to 1 EC2 instance for your web server. But morning 6:50 p.m. you can scale it back up to 10 EC2 instances, because that's your desired capacity between 7 a.m. and 7 p.m. if that makes sense. So you can have a scheduled scaling also. And the most fascinating option is the last one, that dynamic scaling. I don't worry about scaling. Scheduled scaling. It's a dynamic scaling based on my demand. I will create a proper CloudWatch metrics, and as soon as the metric goes above, as soon as the CloudWatch metric goes into alarm state, then I want more EC2 instances to be added. Or that is one way to skin it. Or a simpler way is that there's something called target tracking policy. With the target tracking policy, what you can say is, you can specify what's your average CPU utilization should be. Let's say 50%. So this works like a thermostat, exactly like your thermostat. In your thermostat, if it goes 51 degrees, okay, if it goes to 51 degrees, your AC will be turned on. If it goes to 49 degrees, your heat will be turned on. So it tries to maintain always at 50 degrees, right? So similarly, with the target tracking policy, you can specify that I want my average CPU utilization should be about 50%. It will make sure that as soon as it goes to 51, it will add more EC2 instances. As soon as it goes to 49, it will start to terminate the EC2 instances. Dynamic scaling. Or in fact, you can create your own CloudWatch alarms. You can create your own metrics. And then all you have to do is just tell auto scaling group that whenever there is an alarm on this particular auto scaling group, and define your policies. Yes, add a couple more EC2 instances. So once it goes above 80%, my CPU utilization goes above 80%, add 2 EC2 instances. Once it goes below 30%, okay, to scale in 2 instances. You can absolutely do that. So there is something called scaling policies, right? The scaling policies are triggered based on CloudWatch alarms. You can define your CloudWatch alarms, and you can say that once that CloudWatch alarm goes off, then I want this policy to be applied. Okay, and it ensures the capacity is always between minimum and the maximum. So your scaling policies always they swing between minimum and maximum. So even though your policy says that, let's say you have a minimum of 2 EC2 instances needed and maximum of 10 EC2 instances. Let's say currently you are at 9 EC2 instances, and your scaling policy says that you need to add 2 more EC2 instances when CPU goes above 80% for any of the instances, right? So when it tries to add 2 more EC2 instances, it will check, am I still in the maximum? No, my maximum is only 10. Current capacity is 9. If I add 2 more, then it becomes 11. No, 11 is more than 10. I'm sorry, I cannot do that. So what it will do is, it will only add 1 EC2 instance in that case, because it will only do it until maximum. It will not, even though scaling policy says that add 2 EC2 instances, but it always adheres your minimum and maximum. I hope it makes sense. And policy types, the first one is target tracking scaling. This target tracking scaling is nothing but you have a simple number like thermostat, like an average CPU utilization 40%. Once it goes above 40%, it will add EC2 instances, and it will always make sure that average is 40%. If it goes below 40, then it will terminate the instances. It will terminate the instance until minimum. It will never go below minimum. But if average is above 40%, then it will keep adding these EC2 instances until maximum. So the step scaling is nothing but, that's where you will specify more requirements for your scaling. Like, if CPU utilization is between 40 and 60%, add EC2 instances. But after 60 to 80%, add 2 EC2 instances. If it goes above 80%, add 5 more EC2 instances. You can define your step configuration there. And simple scaling policy says that just you can add only one configuration there. Okay, when this alarm goes off, add a couple more EC2 instances or 1 EC2 instance. So that's about it. And don't get tensed. If it sounds Greek and Latin, we are getting into the actual nuts and bolts. Let's take a look at it and how it works, and I'll make sure you understand it. Any questions before I move on to the lab?
Yes, I got one question.
Sure.
That is, see, this may not be directly related to the current topic, but maybe related to CloudWatch. See, what I'm saying is, see, there's a requirement. The requirement of increase of CPU or something, from which it determines the increase of instances, and it adds. But when it falls, how does it determine that the requirement is less? From a duration, the duration for which a CPU utilization is low for 5 minutes, so you fall. Is it something like that?
Exactly. So you will define your CloudWatch alarms. CloudWatch alarms. Yep. Okay. So I will show you CloudWatch triggering. So we will be doing that example, the one you mentioned clearly. We'll be doing that.
Okay.
So I'm going to show you how to do that. Okay. So
yeah, is this a sticky sessions or the session replication happens on all these?
That has got nothing to do with this.
It's nothing to do with this actually. Generally, I'm asking.
So the sticky session concept comes into picture only when we do application load balancer. So application load balancer does not support that. If you have a sticky session, if you absolutely need it, then you have to go with the classic load balancer.
Okay, yeah, you remember.
Make sense?
Yeah.
Okay.
Scale out means removing the session. Scale
Nope.
in means adding.
Nope, it's opposite. Scale out means you adding the instances. Scaling out.
Okay, yeah,
Use
got
that.
it.
So
got it.
use those terms. Are you guys familiar with vertical scaling versus horizontal scaling? Please go ahead and mute if you're not speaking, okay? So are you guys familiar with vertical scaling and horizontal scaling? Being an architect, you have to know that. So vertical scaling means you're adding more memory to it, adding more CPUs to it, okay? For your instances, you are not adding new instances. So that's called vertical scaling. Vertical scaling has a limitation. You can add memory so much. You can add your CPUs, number of CPUs so much. You can't go beyond certain limit. There is a limit. But with horizontal scaling, meaning you are not increasing your memory or CPU, rather you are adding in new instances. You can add 10,000 instances or million instances. So horizontal scaling is a real scaling. Okay, understand that. So scaling out means adding new instances. So use those terms, as an architect.
One quick question. Sorry to interrupt you. So, how does that, like, if there is any memory leakage or something beyond the control of any machine, then what will happen? Like, it is not really the need there, but there is something wrong with the system, and then in that cases, will AWS be able to identify that? Oh, this is not really something the CPU memory is not really because of the because of traffic or something like that. It is something inherent problem with the system. Will the AWS be able to identify it?
So will AWS be able to identify that? So you have to define your CloudWatch triggering points. Okay, create a new CloudWatch alarm to track your memory, and once it goes above certain threshold, okay, alarm will go off, and then you attach that CloudWatch trigger to your auto scaling group to automatically scale it. So it wouldn't know. So it doesn't worry. It doesn't even have to know any of the underlying stuff. All you are saying is when this alarm goes off, because you define everything, it can be a custom metric. It's not based on memory, not based on CPU. It can be a custom metric completely defined by your application. Absolutely, you can define your custom metrics. When that alarm goes off, just create your scaling policy in such a way that when this alarm goes off, add a couple more instances. Does that make sense?
Yeah, it makes sense, but in the sense that if there is it has nothing to do with any traffic. It is just increased because of the system setup. It's not from outside.
Absolutely. Define
there is no need to have that increase at all. There is something wrong with the system. Logs are actually captured. There is some failure is happening. That's why your CPU
so you don't need auto scaling. Is that what you're saying?
At that point of time, yeah, actually there is no need for auto scaling, but
then don't trigger the alarm. So just don't trigger the alarm, right? Don't create a CloudWatch metric. Then don't worry about it. Then if it's normal, then auto scaling group doesn't do anything about it.
Maybe I think I will explain it in such a way that there is a problem in this. Actually, it's a kind of it's on auto scaling, and then it is supposed to increase when the memory CPU usage is something like 80%, right?
Okay.
And now some of your processes stopped working, or something like it is creating logs, and then your CPU is spiked up like for no reason. But you need that auto scaling in case there is a genuinity in the
It
traffic.
wouldn't know.
Okay,
It wouldn't know your CPU spiked because of, it's writing too much logging, or it's a genuine traffic. It would not know, and you don't want to know. In fact, you don't want this guy to know. You identify from your testing that, or in general, more than 80% CPU, for whatever the reason, it doesn't matter. You really want, alarm to go off, and you really want auto scaling group to kick in and then scale out. Believe me, it doesn't matter what it is, even if it's writing the heap dumps and all. If CPU spikes because of that, you still want your auto scaling group to kick in and scale it out. You really, really want to do that.
Okay, so it will actually add whatever that is required, and then you may not really need it, but you will be just
exactly
make sure that it is running under certain percentage.
You got it. Because it's all alarm based. It's a CloudWatch alarms. Once alarm goes off, you define your policy. I wanted to show you how simple this one is. So yes,
one quick thing: when we scale out, we'll add it, right, based on the CloudWatch. But once it is in the below threshold, it is going to take out, right, all the servers.
We are going to write the scaling policy for that. We are going to write the scaling policy also for that, Ram.
Yeah. So it will wait for all the sessions are going to be cleared off, or it's automatically killed.
Okay. Yes, it will wait for once your ALB is in the picture, right? So that's the most logical case. Your application load balancer. So the new EC2 instances will be added to the ALB pool. When it terminates the instances, it will wait for the connections to drain. That's the industry standard term. Either it's cloud computing or in your own organization, right? So you always want to wait for the connections to be drained.
Okay.
It does wait.
Okay.
Okay. And by the way, I'm glad you brought that up. There is another one called cool up and cool down period also. Meaning when a new EC2 instances are added to the pool, okay, you can specify that after an EC2 instance is created with its appropriate AMI and the launch configuration template, wait for, let's say, 60 seconds for the application to come up. So it's like a warm up period. It's like a bootstrapping. Let's say your Java or C# application to come up and proper database connections to be up and caching loaded, all of that. That's called bootstrapping, right? So there is a concept of, it's a warm up period. I'm going to show you those settings also. So anyways, does it make sense, Ram?
Yes. Yeah.
Wonderful. So go to EC2 dashboard here. Okay. Go to here on the left side here. You have load balancing and you have auto scaling. So by the way, what I have to, before I start this exercise here, is that go to AMIs. We have created this AMI. I have a web server AMI. This is my web server. It does, it has a simple H1 tag, okay, saying I'm a web server or something like that, right? So I have a Amazon machine image. So I'm going to create a new launch template. It's called within auto scaling. Click on launch configurations. Or actually, there are two ways you can do auto scaling. One is using the launch configurations, or by clicking on the auto scaling groups and then create a new auto scaling group. When you create a new auto scaling group, see here, there's something called launch template. So before you define your scaling policies, okay, tell me what is your launch template look like? Meaning, what EC2 instance you want me to, what's the AMI for your EC2 instance? What instance type? Is it T2 micro, T2 C4X large? What is the instance type? And then what security group do you want me to put it? What key pair you want me to use it? Does it make sense? And also you can even specify that whether you want spot instances to be, whether you want it to whether you want on-demand instances or spot instances. You can even specify that. Let me show you that. So the first step you want to do is, after trying to create an auto scaling group, click on launch template. So create a new launch template to start with. Okay. So what is my launch template? Is my launch template name is web servers launch template. I would say web servers. Okay. Or web server. So, and with the launch template, the beauty is you can specify the template version. So you can say prod web servers. Okay, this is like your versioning. You can say prod web server 1, and then you can maintain. You can take the previous version and then you can upgrade it. Okay, so this is just a description. And then auto scaling guidance, sure, we'll take the template tags. I don't have any tags. I don't want to give any tags for that. And you can copy, if you already have an existing template, you can copy from the source template. I don't have it because I'm creating a brand new one. Okay, guys. So when auto scaling come into picture, it is going to use this launch template. This template will be used to launch the new EC2 instances. I want you to understand that. When auto scaling kicks in, when it has to scale out, it is going to use this launch template to create new EC2 instances. So Amazon Machine Image, AMI, what AMI do you want to use it? The multiple AMIs. Let's go to my AMIs. See here, my AMIs, my web server AMI. This is what I wanted. This is what I just showed it to you, right? So I want my AMI and instance type. What instance type do you want to do it? I want to do it on T2 Micro because I want it to be free tier eligible. Key pair. What key pair do you want to use it when you want to log into these EC2 instances? Sure, use the batch 3 key pair that I already have it. Network settings. When auto scaling automatically create or provision these EC2 instances, where do you want these EC2 instances to be provisioned in? Well, a virtual private cloud, a VPC, so which is the default VPC. And I don't want EC2 Classic. EC2 Classic is a old school approach where there is no, before VPC has come into picture. So it's a very legacy. So do not worry about it. It's VPC, and we are going to talk about the VPC, for the complete weekend. So security group. So when a new EC2 instance is provisioned, what security group do you want it to attach to? Well, web server security group. Okay, want to create web server security group. Well, storage. It is coming from AMI. This whole thing is coming from AMI. 8 gig general purpose SSD, delete on termination, yes. Encrypted, no. Obviously encrypted is no, so I don't need key. So this is all coming from AMI. And resource tags, I don't need any tags. I don't need any network interfaces. Advanced details, if you want to specify, see this one. If you want to request spot instances, you know what spot instances are. These are, you'll be bidding for these EC2 instances to save the cost by almost at about 80%. And shutdown behavior, if you want hibernation or not. See this one, termination protection. So the termination protection means if you turn on termination protection, then it will only scale out. It will not scale in. It will not terminate the instances automatically. You will have to go and terminate it if you have the protection enabled. Okay. So I'm not including it in the launch template. And there's a concept of T2, T3 unlimited. So
what's the advantage of termination protection?
In case, if you do not want auto scaling to automatically terminate the instances, okay? So let's say you are writing something on the disk, and you don't want to do it. You wanted to, before, you want, based on the demand, you want EC2 instances to be scaled out. But when it comes to scale in, you want to take a second look at it and make sure that the termination is okay. In that case, you want to protect it. Okay. If you want to use any user data, you know what user data means. It's a bootstrapping script. If you want to do that, you can do it, but I'm not touching any of that. I'll leave the advanced details as is and create launch template. So my launch template is created now. So what do you want to do after the launch template is created? Well, I want to create a new auto scaling group. Auto scaling group will use this launch template to create or to provision new EC2 instances. So create an auto scaling group from your template. Let's go to create auto scaling group. So, or you can go back and then go back to auto scaling groups, and you can create a new auto scaling group. Or if you go to your launch configurations, auto scaling groups, where is that? Create an auto scaling group, and your launch templates here. So my launch template is the one I just created, web server launch template. Sure, use it and give a name to your auto scaling group. I will say next step web servers auto scaling group. Yeah, that's exactly what it's doing. So launch template. So I told you what a launch template is. We just created a template. That template contains what is an AMI, what instance type it is, what security group, what key pair, everything includes a template. And now it will blindly use that template to create the new EC2 instances. Make sense? So it's a web server template, and the version number, it's a default is 1. So you can, the beauty with the launch template is you can create multiple versions of template. So you can create a new launch template, and you can copy from the previous source template. Yeah. So not a big deal. It's using your web server template. Essentially what it's doing is it's a prod web server. That's the name we gave, description. And it's instance type is T2 micro. Key pair is batch 3. Security group is this one, which is our web server security group. That's it. Pretty much it's using the launch template. Click next. Now, so purchase options. Do you want to, what kind of purchase options? Do you want any spot instances to be do you want any spot instances? Do you want any reserved instances? Any of that? Okay. So this option is, the simplest option is adhere to launch template. In launch template, we said no spot instances. So I will not put any spot instances, meaning everything is going to be on demand. In the network, okay, so I know in the launch template you specified it's going to be VPC, but what VPC is that? It's a default VPC here. There is only one option. So what is virtual private cloud? We'll be talking about that later. And then within the network section, guys, when a new EC2 instances are created, where do you want them to be created? In what availability zone? Well, I want them to be distributed across all the availability zones. I'm in Ohio region, and there are 3 availability zones in Ohio region. And I'm going to pick all 2A, 2B, 2C, all 3 of them. Because when 6 EC2 instances are created, I want 6 to be distributed across all 3 availability zones so that I'll be safe. Because even if one availability zone is down, then I'll still have 4 EC2 instances. Make sense? Let's go to next. Okay. So here, this is an important step. Do you want these EC2 instances to be part of load balancing? Ideally, absolutely. But right now, I'm going to show you with no. Please leave this as no, and we will come back and do one more exercise where I'll say, yes, I want the load balancing to be done. Okay. And health checks. So what kind of health checks? What kind of health checks do you want auto scaling to perform? So what is the concept here, guys? Auto scaling will make sure, in a most simplistic scenario, it will make sure the number of your desired capacity is always that way. If you say that you need 5 EC2 instances, it will make sure that all 5 are good. Okay. How does it know that one instance is unhealthy? How does it know that? So by default, this EC2 instance type is checked, meaning if instance is stopped, that is when it will think that auto scaling will think that this EC2 instance is unhealthy. Let me terminate it and create a new one based on the template and add it to the pool, add it to the group. But if you enable the load balancing, then you can rely on load balancing health checks. Remember, we created a / health check.html. You can do that. If you specify this one, then it will rely on application load balancing health checks. But I do not want to do that because I want these two will go hand in hand. If I want my EC2 instances to be part of load balancing, then I want my load balancing to, I want to rely on load balancing health checks. Meaning if EC2 instance could be healthy, but Apache may be down, then I want my ELB to tell me that, yes, my instance is unhealthy. Then auto scaling will kick in and then terminate the instance, create the new one and add it to the pool. Now, health check grace period. The amount of time until EC2 scaling performs the first health check on new instances after they are put into service. Do you want to wait for any number of seconds before they start health checks? I want to put only 30 seconds because mine are going to be pretty straightforward. If you have a larger application that needs a lot of bootstrapping, then you want to give some more number of seconds. Okay. Click on next. And then there you go. Now this is the group size. So what's your desired capacity? So you just mentioned, in your case, you want 3 EC2 instances. You need 3 EC2 instances for your web servers to be healthy, right? So just bump up your desired capacity as 3. But desired capacity must be between minimum and maximum. So you can say that your minimum also number of 3, maximum also number 3. So this is the most simplistic auto scaling setting. What you are saying with this desired capacity same as minimum and maximum is that I know my capacity needs. You don't need to automatically scale it. Please keep all the time that please make sure that there are 3 EC2 instances from a web server. If one of them is down for whatever the reason, if one of them is unhealthy, then please terminate the EC2 instance, create a new one and add it to the group, please. That's what you are saying with this example. It's a most basic one. We will come back and complicate the things. So this is a scaling policies. Well, I'm saying none. I do not have any scaling policies yet because I'm taking a manual route here. I know my scaling needs precisely. I want 3 EC2 instances. Make sense? We will get back and complicate the things. This is instance scale in protection. If you specify enable instance scale in protection, if protection from scaling is enabled, newly launched instances will be protected from scaling by default, meaning it will only scale out. It will not scale in. It will not terminate the instances. It will leave them until you come in and verify manually. So I'm not going to select that. Click on next. Any notifications? Send notifications to SNS topic whenever Amazon EC2 auto scaling launches or terminates EC2 instances. If you want to do that, you can do that. And we have our topic, EC2 high CPU alert topic we created in the previous class. Okay. What kind of notifications when your new EC2 instance is launched? Please let me know. When a new EC2 instance is terminated, please let me know. Fail to launch, let me know. Fail to terminate, let me know. In all the cases, let me know. Click on next. Do I want to create any tags? Not really. Just click on it and make sure, just review it. Make sure it's good. So this is my launch template, my settings. Well, I made sure my EC2 instances will be distributed across all 3 availability zones. My load balancing I disabled to start with. We will get back and make things complicated. This is the simplistic example. Health checks is based on EC2. I'm not enabling ELB health checks, load balancer health checks yet, because my instances are not part of ELB anyway. So it doesn't make sense. My group size is desired capacity 3, minimum 3, maximum 3. That means I know my capacity. Just make sure that these 3 are good all the time. So what we're doing here is this lame example here. Maintain current instance levels at all times. This is what we're doing. We are maintaining current capacity. So we are asking auto scaling, please maintain 3 EC2 instances all the time for me, for my web server. No scaling policies, no complicated things. And then we want notification to be sent. So create auto scaling group. Let's go and create it. So this is your auto scaling group. It's getting created. Desired capacity 3, minimum 3, maximum 3. So when it sees a desired capacity, it will start with the desired capacity, and then it swing between minimum and maximum based on your scaling requirements. But in this case, we kept all 3 of them as same. Go to activity. There you go. It's a pre-in-service state, meaning it's pre-initialization service. This is in progress. Sure. See this one? At 2020, this time frame, a user request created an auto scaling group, changing the desired capacity from 0 to 3. Yes, so we started with 0 to 3. At this point, an instance was started in response to a difference between desired and actual capacity, increasing the capacity from 0 to 3. So that's why there are 3 EC2 instances that are getting kicked off automatically. Let's go to EC2 dashboard. We should see 3 EC2 instances that are getting created. Absolutely. These 3 are created by the still initializing. So these 3 are created by auto scaling group. Make sense? We'll wait for this initialization to be complete, and then we'll log into one of them and see if it's how is it looking, how it's looking. I'll log in as root. Let's see if Apache is running. Yep, Apache is running. Because my AMI has a script.
That is only in one of the instances, right?
I'm logged into only one of them, but everything should be same, right? So your heartbeat.html is there and my index.html is there. So let's go to index.html. Hello from server 1. I think we should see the same thing across all of them. So let's go take a public IP address and try going into that. Hello from server 1. Beautiful. You should see the same thing from this guy also. Copy it. Hello from server 1. We should see that. Go to server 3. And please make sure the availability zones, guys, one instance in 2A, the another instance in 2B, the third one is created in 2C. Beautiful distribution. That's exactly what I want to see it. Either you can go to public IP or public DNS name. I'll use public DNS this time just to show you guys it's the same thing. Beautiful. Make sense? Now, let's go to auto scaling groups again. Click on this guy. Activity. So all of them are successful, right? Now, what did we say our, where is our details here? Minimum capacity, where are our health checks? So what did we say our health check as? Health check type is EC2, meaning if EC2 instance is stopped, your auto scaling group will kick in. Your auto scaling will continuously check for the health of your EC2 instances. At any point, if it finds out that an EC2 instance is unhealthy, it will terminate the instance. It will create a brand new instance from the template that you provided and add it to the auto scaling group. Does that make sense? So what I'm trying to do is, there are 3 EC2 instances here. I'm going to kick off. What I'm going to do is I will take this instance in 2C, US East 2C. I'll go actions, instance state. I'm going to stop it. Are you guys with me so far? I'm stopping the EC2 instance. My auto scaling is continuously checking for the health check. And what is the health check type? What happens if I stop Apache on this instance? Your auto scaling will not know that.
Will terminate and create the new.
In this case, is only stop or running. That's it, right? It's not checking if like my healthy HTML we wrote like with the load balancer. Okay.
So here in auto scaling group, I want you to understand this one here, guys. So the health check type is EC2. What it means is it will depend on EC2 status. If EC2 status is stopped or termination, if it's stopped or terminated, then it will consider unhealthy and it will create a brand new instance based on the template that you provided and added to the group. So my point here is that if you log into this instance and stop Apache, your auto scaling will not kick in because your instance state is still running. It will think that my EC2 is absolutely healthy. It doesn't know that your Apache is down because that's not how you defined the health check. You said the health check is based on EC2 instance. Does that make sense? Later on, we will complicate the things. We will change that setting to ELB. Then it depends on ELB health checks. I just paused for a second here. I want to make sure you guys are okay with that. Wonderful. So I'm picking up the instance in US East 2C and I want to stop this guy. Actions, instance state. I want to stop the EC2 instance itself. I'm not talking about stopping Apache. I'm talking about stopping the virtual machine itself. I'm stopping it. Now, let it be stopped. Let's wait and then go back to auto scaling group here and then go to our auto scaling group, go to activity, and then there's nothing there. Let's keep refreshing. Let's keep refreshing because it checks.
I got a question here.
Yes.
See, you said you're stopping the instance, but not the Apache. But if you stop the instance, the Apache is installed inside that instance. So that will get stopped automatically.
Of course. Apache is gone.
Okay.
You totally got it. So let's go back to EC2 dashboard. So wonderful. So it is stopped. So let's go to auto scaling groups. Kick off our auto scaling activity. So let's keep refreshing. Let's give a few seconds here. So it's going to say that you will see one more activity here. It shows that my desired capacity is 3, but the actual capacity is 2. So I'm creating a brand new instance from the template and adding it to the group and increasing the desired capacity to 3. Changing the actual capacity to match the desired capacity.
So auto scaling has already kicked off, right? Now we are just waiting for the process to complete.
No. Auto scaling is continuously checking the health check, right? It's not there. So it's just a matter of time, within a minute it should kick off. So.
Oh, okay. By kicking off, I mean making the health check.
Yeah, exactly. As soon as it finds out the health checks, once it identifies that it stopped, then it will kick off. We will see that in auto scaling group. We will see that here first. See that desired capacity. Okay, actual instances. See, it is still showing that instances are 3. So from auto scaling perspective, there you go. In progress, terminating EC2 instance. See this one? At this time, an instance was taken out of service in response to a EC2 health check, indicating it has been terminated or stopped. So we stopped it, but it is terminating it. That is the first step it's doing it. So it is terminating it, and then terminating is successful, and then pre-initialization service state, launching a new EC2 instance. Take a look at this. At this time frame, an instance was started in response to a difference between desired and actual capacity, increasing the desired capacity from 2 to 3. There you go. So it is doing it. It's a still pre-initialization service state. Now it is successful. At blah, an instance was started in response to a difference between desired and actual capacity, increasing the capacity from 2 to 3. Now let's go back to EC2 dashboard. Now we should see 3 instances. See this one? Initializing. And this is terminated. The previous one, we only stopped it, but auto scaling group terminated it, and it kicked off a new one and added to the group. And beauty is, we stopped an instance from US East 2C, it created another one in US East 2C, because it realized that there are 2 instances in 2A, sorry, 1 in 2A, 1 in 2B, and it tried to distribute the new EC2 instance by putting it in 2C.
Where did we specify the availability zone go round robin?
In the networking. Not in the round robin. We didn't say round robin. What we said is, in the network section, what availability zones do you want? Subnets within the VPC, and we specified subnet. We picked all 3 subnets. If you had picked only 2A and 2B, then it would have provisioned your EC2 instances only in those 2 availability zones. Does that make sense?
Yeah, okay, got it. Thank you.
Yep. So a new one got initialized in 2C, and this is your public IP, and yep. So there's no magic there, it's working. And if you really look at it, the instance type is T2 micro, and your security group, take a look at your security group. Everything we defined it in the instance launch template, right? See this one? Your security group is web servers, and your key pair is batch 3. See it matching. Does that make sense?
But Venkat?
Yes.
Where did we mention that T2 micro? It has to create only T2 micro instance type?
In the template. In the template.
Okay.
Absolutely. Sorry, go ahead. Go to. There is a second way. One is through launch template. One is called launch template. The other one is launch configuration. So between launch configuration and launch template, they are very similar, but launch template, with the launch template, you can version your templates. You can say your production version 1, and then you can say, when you create a new version, you can say that please copy from production version 1 and then make necessary changes. So always use launch template instead of launch configuration. That is recommended by Amazon also. Actually, launch template is little newer. Okay.
So in case of this one, right? When we use the version, can we go back to the old versions and create it?
Can we go back to the old one?
So you have version
you can maintain
2, 3,
multiple.
4.
Sure.
You had 2, 3, 4.
Yep.
And then you can go to either 2, 3, or 4, any version.
You can maintain that. Yep. You got it. You can maintain the versions, and you can go back to the old ones. Yes.
Venkat, this new instance just created is not gonna keep the same IP address, right?
Absolutely not.
Okay.
Of course not. In fact, the same EC2 instance itself, you stop it and start, your IP address will change, right?
So in that case of auto scaling, I cannot use this in my route 53 like
you
this,
totally
right?
got it. You totally got it. And you do not want to use it because you want to use your application load balancers DNS
Yes.
name in your Route 53.
Yep.
You must not do that. So somebody asked a question, where did we mention T2 micro? See this one, instance type is T2 micro. This is your launch template. Okay.
Venkat,
So, go ahead.
when it is creating the new instances, is it going to create completely brand new with code or without code? How it is going to work?
Of course, it's with code, absolutely with code, because your code is in AMI. You agree? Your code is in AMI. With your gold version of your code, let's say you are building a Java-based application, you have your Tomcat, okay? I'm just picking up an example here. Let's say you have your Tomcat, your Java JDK 11, your Tomcat 9, and then let's say you have your web application. Let's say ram.war file, yeah? So, or let's say, let's say you have like online shop.war file. You put that code is deployed here, and only after that thoroughly tested, you took an AMI, right? AMI is a gold copy of your all of the EBS volumes that are attached to your EC2 instance. Now, if I spin up a new EC2 instance, forget about auto scaling for a second, Ram. It's for not only for Ram, it's for everybody. Forget about auto scaling for a second. If I launch a brand new EC2 instance from an AMI, am I not getting the code?
Yeah, you are. Yes, you are
Absolutely.
good. Yeah.
So your launch template completely relies on your AMI. AMI is one of the biggest configurations in your launch template, right? In your launch template consists of what AMI do you use, what instance type do you use it, what security group do you use it, what key pair do you use it. All that settings combined together is your launch template. So with the launch template, forget about auto scaling, you create a new instance, absolutely your code comes. Okay. Am I making sense?
Yeah, but in the real world scenario, if you give this auto scaling and everything we mentioned, right? After that one, I went to my running instances and apply patches or something. Okay.
Sure.
So do I need to recreate the auto scaling group, or is it going to get all the patches and everything automatically to the new server?
No, it will not automatically get it, because you have to change your AMI first of all.
Okay.
You change your AMI. So even after you change your AMI, I want you to understand that your running instances will not be touched unless they are unhealthy. Make them unhealthy. Then change your AMI. Then all the new instances that are created from that AMI, from that point onwards, will utilize your new patching.
Okay. So on the AMI, we are going to apply the patches. We don't have to touch the security groups, right? In that case, even if we create already.
You got it. You got it.
Okay.
Yeah.
We can update the existing AMI.
Can you update an existing AMI? No, AMI is just a snapshot, right? Because your EBS volume snapshot, right, Kiran?
Yes.
So what you want to do is you launch an EC2 instance from that AMI. As Ram was saying, apply your security patches or change the new code. Let's say you have built a new code, deploy that new code there, test it in that specific EC2 instance, and then once you're comfortable, now create a new AMI, and now you change your launch template to point to that new AMI.
Got it.
Make sense? And now go to your auto scaling group and change to your new launch template if you have a new version of your launch template, and then go to your existing EC2 instances and make them unhealthy one at a time, and then your auto scaling will kick in, and from that point onwards, if you use that new AMI, a new launch template to create the new EC2 instances, which internally using new AMI, which has new code, new security patches and all, it will spin up and then do. Does it make sense?
Got it, Venkat. Yeah, you're right. Yeah.
Okay. Now, see, when you selected that my AMI, which is your AMI that you created, that time, see, there were a lot of other AMIs.
Yes.
Oh, those were all created by
AMIs.
you, or those are community marketplace?
Those are community AMIs and
okay.
Yep.
Okay, and one thing that I probably should have known by now, that is, see, for one AMI is for only one instance, right? You cannot have couple of instances and have an AMI for that, right?
Couple of instances having.
Yeah, suppose you bundle 2 instances and make one AMI out of that.
No,
You
you're right. Yep. Only one of them. Because Amazon machine image, you can't say, so let's say you have a one machine that has Apache and you have another machine that has Tomcat. You can't pick you can't create one single image from both of them in real world also. Can you? No.
No. Yeah.
Because one is an Apache image, the other one is a Tomcat image, if that makes sense. Yeah.
And in real world scenario,
This is
Go
how
ahead.
we can roll out different versions in the different regions, right?
Can you repeat that?
I mean, by applying different machine images, we can roll out different versions of the application in the different regions.
In different regions. So once you
Let's
have,
say you said in Japan, suppose they want to roll out a new feature, so they can apply a new machine image that they want to in that region.
AMI, go ahead.
Yeah, go ahead. I mean, I think
No, AMI is a region specific. Okay. So what you have to do is you want to do, if you really want to, now you are in Ohio, this AMI, it's not, I want to take that offline a little bit. Okay. So let's say, but I'll answer at the highest level. Okay. So this AMI is in Ohio and you want to push this to Japan, then copy AMI. And at this point, you can specify the destination region. And now you push that to, you push that to Japan. And now log into your, change your region to Japan. And now you have an AMI there. Create, if you really want to change that, then launch a new EC2 instance from that AMI, make the necessary changes that are required for Japan, create a new AMI. Does that make sense?
Yeah, got it. Thank you.
Yep.
And also auto scaling is also region specific, I guess.
Absolutely. Go ahead.
So
Anyone?
AMI is like a Docker image, right?
Exactly.
in
But it's
real,
at the OS level. Docker image is at the container level. But its concept is similar. Yes.
so in real world scenario, is there a setting to create the AMI automatically at a scheduled time, and that can it be pointed to the to this scaling group so that all the updates get reflected in the newly created instance?
That's a very good question. Yes, you can create using API SDKs, or there is something called AWS CLI, command line interface. You can do that, or even there is a more automation technique called cloud formation template. Yes, you can do that, but in real world scenario, everybody listen here, okay? In real world scenario, what happens is, as part of your deployment, let's say you changed your new code, you pushed your new code. As part of that, you will create a new AMI from that, and then update your launch template and auto scaling group. Because does it make sense? After you deploy the new code and create, as part of your deployment process, you created these, you deployed this code across all of your EC2 instances, right? Now take one of them and create a new AMI, and then put it out there and update your launch template and use auto scaling group as part of your deployment process itself. Do all of that so that from that point onwards, your auto scaling group has been updated to utilize the new code.
Makes sense. That's great.
Okay.
So how is the AWS CLI?
It's a command line interface. You will use your command line, commands. We will be looking at it in S3 when we talk about S3. I'll show you. Okay.
Okay. And another thing is the spot instances. We're going to talk about it later, right?
No. That's all it is. For the spot instances, I want you guys to kind of read about it. So spot instances, and there's something called spot block. Okay, read about it. It's spot instances is the cheapest way to get your EC2 instances out of all the 3 options. Okay. It's just bidding. There's nothing more than that. There is something called spot block. That's the only probably point for the exam. Yes.
One more question.
Absolutely.
You're deploying it to the production. Suppose take here we have A, B, C3 within the Ohio region.
Availability zones. Let's use the terms.
Yeah, availability zones. So I want to roll out a new version of the application. So I want to take one out of the load balancer.
Yep.
And deploy and thoroughly test it. Once we are comfortable, we need to roll out to all the other three. Out to. So how we can take that out of the pool and apply the new machine image or the new application version?
You can manually do it. You can manually do it, or use APIs and write a code to use your APIs, leverage APIs, or write the cloud formation template. You can do that, correct? Okay. But it's again not directly related, but I'll tell you some other DevOps principle called blue-green deployment. So in the blue-green deployment case, what happens is you have an application load balancer, and if you're behind ALB, let's say you have 5 EC2 instances, you don't want to take one at a time and do it. I would say take a new load balancer and create a copy of a same five EC2 instances. In this, deploy your new code across all of them. Test it thoroughly in your blue environment. Let's say your green is production. Okay, I'm calling it exact replica, but deploy your new code. I'm calling it as a blue environment. So you test that thoroughly, run the complete regression suite on them. Once you are satisfied, so it's just a matter of a DNS blip. Change your Route 53 from this ALB DNS to the other, from your green ALB DNS to blue ALB DNS. And how long did the deployment take? 0.1 seconds.
That makes sense, Venkat. Yeah,
and that's exactly how you want to deploy it. You don't want to do it instance by instance. Blue-green deployment. Read it.
It retires the blue one.
Can you say that again?
You need to retire the other version, right?
Yeah. Now, whatever is in production, now that became green. Okay. Or in some companies, what they do is now to start with, green was in production, blue was in, non-prod. Okay. So now blue became production, green became just outside of it, right? So now either completely bring it down or use it for your next release. You continuously have it, right? Release 1 is in production now. Now your blue is in, blue is not in production. So use that for release 2. Now, at the time of release 2, you just swap them again. You continuously swap them. So you will never, ever be down for the deployment. That is the new way of deploying it. It's not really new. It was mentioned in continuous delivery book probably a decade back, this whole this whole concept. But the beauty is, if you really want to use the blue-green deployment, you have to use the database scripts properly, because in the database you don't want to do any destructive changes. You do not want to do drop columns and such. Drop column is a bad idea, or renaming a column is a bad idea. I'm going outside of the auto scaling this one because I'm excited. I'm always excited when we talk about that, because that's the right way to do it, but not now. Okay, Ramesh, another last question.
I think pretty much answered, but the thing is, we are going to have 2 sets of instances, right? One for blue and one for green.
Two sets of instances, exactly. If you have 9, go ahead.
Yeah, that's my question.
Yep, exactly. So in my previous company, as I was saying, we had about 95 instances, right? So we had 95 instances for blue and 95 instances green. We never deployed. We were never down for any deployment. It's just matter of DNS flip. Within a DNS, you just change the ALB. That's all it is. So you don't want to be down for, Make sense?
I'm asking all these questions based on current company.
Venkat?
Fair, Karan, yeah.
But when one instance is active, right? But other instances are ideal, right? So why do we have to pay for those?
It's not one instance. We are saying one. one suite of instances.
Yes, one
Absolutely.
suite of instances.
Because you need another suite of instances to work on your next release, right?
Mm-hmm. But most of the time they are ideal, right? So that's it.
No, if you don't need it, terminate it.
Oh, okay.
How many days does it take to create it? Does it take 5 minutes to write a script and create it? The entire infrastructure?
Yeah, that's right.
30 minutes? A big company, 1 hour? That's all it is. So how long does it take to create a new instances? Keep your AMIs, pay them. Or you don't even have to do that. In fact, you create cloud formation template, or just write your own script to deploy it. It takes 1 hour. Don't pay it. Architect it properly. Make sense?
Mm-hmm.
One last question, Venkat. So when we go for this, yeah, go ahead. So when we go for the auto scaling group, right? Using a new AMI, is it updated or is it created a new group?
Is it updated or created?
I mean,
what do you mean?
No, auto scaling group is newly created, or existing one is updated with a new AMI. So you have a new AMI.
I have an AMI to start with. Okay, let me see.
You have an AMI. You created one ASG that is done with. Okay,
absolutely.
Now you have a new AMI. You changed it.
No, I did not change it. One second. That's where I think I'm lost. We have an AMI called my. Let's use this name.
No, he's saying suppose. He's saying suppose you change it.
Oh, you're saying supposing. Okay.
Version 2, you
gotcha.
would say.
Gotcha. Fair. Thank you.
So are you going to create a new ACG, or are you going to update the existing one?
Update the launch template, because auto scaling group depends on launch template. Launch template has your AMI. Update your launch template to point to your version 2 of your AMI, and your auto scaling group is all set. Does it make sense?
Yes, thank you.
Yes, yep. but if suppose production is running, like suppose OLTP or batch something is running, because of these kinds of changes and all these things, it won't affect the process.
You are creating a brand new AMI, right? And when you create a brand new AMI, you are creating a brand new AMI from a brand new EC2 instance. I'm assuming something that is outside of a production pool.
Yeah,
you don't want to create.
No, but in the this thing, the one that is increasing and decreasing, what's that called? Does
auto scaling?
Auto scaling. Over there, you have production instances running, right?
Okay, makes sense.
And over there, some production activity is going on, and in the meantime, you apply.
Yeah, I understand what you're saying. Yeah. So when should this new AMI to kick off? That's your decision. You pick a time like a midnight at some point, and then update your launch template to utilize this new AMI, and then go make each one of them unhealthy, and then your new ASG will kick in. Make sense? Excellent. All fantastic questions. So let's go back to auto scaling group. This is my auto scaling group, and this is my simplest setting here. And let's go to activity. We looked at the activity. We know what it is. We understand what's EC2 health check means. Okay, health check EC2 means. Now let's go to automatic scaling. We do not have any scaling policies at this point. Here you can do it in 2 ways. 1, scheduled actions. Create a scheduled action. You can. So if you know that your desired capacity is 30, okay, during a specific time frame, let's make let's say scheduled action midnight. Let's say QA termination. Yeah. So desired capacity is, let's say, 1. Minimum is 1, maximum is 1. Recurrence every day at certain cron. So this is your default cron, midnight. But if you have a different cron expression, put it here. Let's say 5 o'clock. Then you just specify your whatever this one is, minutes, seconds, minutes, hours. If I, let's say if I want to do it 5 o'clock, I believe that's what it is. That's what it is. If it's, you understand what I'm saying there. Okay. I may not be perfect in the cron, but you understand what I'm saying. So midnight. So the first time it should be scheduled tonight, create. Okay, could not be created given start time is in the past. Okay, sure. Let's start from tomorrow because it's midnight, right? Is still in the past. Okay, so
At the UTC.
So I'm say that again. Yeah, it's a UTC. So at this time frame, your desired capacity has been set to 1. It will automatically do that, and you can create another scheduled action, QA, SLA up. Whatever that one is, your desired capacity is, let's say 3. Bring it back. I'm still using most simplistic example here. Cron 0, 23, whatever. Okay, that's something like that. Scheduled action with this start time already exists. Okay, so oops, this is a different time frame. So let's say it's 7 a.m. Okay, so essentially my point here is that after 7 p.m. at 7 p.m. terminate this. I should have changed this one to 7 p.m. I'll change this recurrence to 7 p.m. if I know exactly what that cron expression is. But you understand the point. I'm not trying to be perfect here. But the point is, I want my instant desired capacity to be 1 from 7 p.m. until 7 a.m. So from 7 a.m. until 7 p.m., I want my desired capacity to be 3. That's it. Everything will be taken automatically. Does it make sense? You can have your, if you know that if you know your capacity needs, if you know your capacity needs, and if you know that, every day I need 3 instances in the daytime and only 1 instance in the nighttime, you understand what I'm saying. So that's your scheduled actions. This is not fun. Let me go ahead and delete it. So this is not fun. The fun is scaling policies. So let's go ahead and add a new scaling policy. So here, there are 3 types here. You have your target tracking scaling policy, step scaling, and simple scaling. I'll say target tracking scaling. This is actually a very simple one. This is like your thermostat, okay? And I'll say this one is a CPU, average CPU utilization. Okay. So my metric time is either average CPU utilization, average network in, network out, or application load balancer request count per target. If per target, meaning per EC2, if it can handle 20 requests gracefully, put that number 20 here. So when the 21st number came in, okay, per target, then auto scaling will kick in and then add a new EC2 instance. Once it goes back to 19, then it will terminate the instance. It will, this is like your thermostat. It will always try to keep, let's say your CPU utilization, right? But keep this in mind, average CPU utilization across all the instances in the group. I want you to understand that one target may have meaning one EC2 may have 40% utilization, the other one may have a 60% CPU utilization, the average is 50%. So if it goes above 50, then it will kick in. It will scale out. If it goes to below 50, then it will scale in. It will swing between based on your min and max. So your instances need dash seconds warm up before including in metric. So do you want to wait until your machine is completely, your instance is warm up? Either you give 30 seconds or 60 seconds or even 300 seconds based on how much bootstrapping time you need it. After that, after 60 seconds, it will start the metrics for that. Make sense? So disable scale in to create only a scale out policy. This is what the protection. If I select this one, then it will only scale out. It will never terminate the instance. I don't want it. So this is your target tracking scaling policy. Makes sense? This is your target tracking scaling policy. Now let's go ahead and add a new policy. This is your target tracking, and let's go ahead and do a simple scaling. So in the simple scaling, let's say, see here, I have a CloudWatch alarm that we created last time, EC2 CPU utilization above 80%. So if any CPU, any target CPU, average may be below 50, we got average CPU covered through the through the target tracking scaling, right? The one we just created it. But if any instance goes above 80%, I want a new instance to be added. So I'll say instance specific CPU 80%, something like that. Some name you give it, and see here. Read this one. It's a simple algorithm. Breaches the alarm threshold. CPU utilization greater than or equal to 80 for one consecutive periods of 300 seconds for the metric dimensions. Okay. So for a specific instance ID here. Okay. So this CloudWatch alarm is specifically for this instance. Now, if you want across all the instances, go change this one. See, this is the instance ID. This instance may not even exist. Okay. But I just wanted to show you guys how it works. So take action, add. Do you want when alarm goes off with this CloudWatch alarm, okay, do you want to add 0 capacity units, or how many do you want to do it, or you want to do a percentage of group? So I'll say 1 EC2 instance to be added is what I want to say. And then wait how many seconds before allowing another scaling activity. So we just kicked off, right? So wait for 5 minutes. Wait for 5 minutes before another scaling activity happens, meaning another add or removal happens. So wait for 5 minutes. Create a new scaling policy. That's it. So this is your simple scaling policy. Make sense? Let's go ahead and create a new policy. And step scaling. In a step scaling, let's say, sure, this is a CPU utilization, but in a different way, CPU utilization step scaling. So CloudWatch alarm 80%. No, I want to create. So in using step scaling is a little complicated. Okay. So let me open my notepad and then show you what my intention here. First, let's define the intention. My intention is if CPU goes, I think 50% we got it, 80% we got it. I mean, I'm just showing all of them in a single auto scaling group. Generally, it's not fair to do that, but I'll put. So if CPU is between 50 and 60%, okay, add one EC2 instance. This is first step. It's a step scaling policy, right? The second step is if it is between 60 to 70%, add 2 EC2 instances, meaning something is going on, meaning we may have gotten more load or something bad happened. 70 to 80%, or we can say about 80%, 80 to infinity. Okay. Add 5 more EC2 instances. Like that. You can specify that. This is a step scaling option. I can show you that. So I don't have a proper CloudWatch alarm for that. If you want to create it, please go ahead and create a CloudWatch alarm. select metric, EC2. Do you want to do across all instances or per instance metrics? Actually, I want to pick across all instances. Let's say CPU utilization, select metric. So if average CPU utilization within 1 minute, okay, if average, see this one, average CPU utilization within for a period of 1 minute, if this one is greater than or equal to 50% or 60%, you can create you can create a name for this in alarm. Select an existing, if you want to send any notification, you can do that, or otherwise select a notification. Select an existing, create a new topic. Okay, okay, I'll use this one. Create a new CPU 50. Did I give 60? Wonderful. Let's go ahead and create it. So this is for CPU 60%, right? And now we can go ahead and create a new alarm. Select metric, EC2, across all instances, CPU utilization, select metric. This time what I'm going to do is, if it is less than or equal to 30%, my notifications are bad, so please don't, those, what do you call, those topics are bad. CPU 30%, okay, below 30%. So if it is below 30% also, I want an alarm to go off. It's below 30%. This one is above 60%. Make sense? Now we have two CloudWatch alarms, right? Let's go now to this guy here, auto scaling group. This is the new auto scaling group. Sorry, existing auto scaling group, automatic scaling. We have two auto policies. Let's create a new policy. You can do a step scaling, step CPU, some name, CloudWatch alarm. If it's above 60%, see here guys, add 1 CPU units when it is between 60% and let's add 2 step. If it is between 60 and 80%, then I want 1 EC2 instance to be added. But if it is between 80 and infinity, then I want 2 EC2 instance to be added. Does that make sense? You can add something else in between. Okay. So if it is between 60 and 70, then add 1 EC2 instance. If it is 70 and 80, then add 2 EC2 instances. If it's 80 and infinity, then add 5 EC2 instances. This is what a step scaling policy is. Does it make sense? So if the CPU utilization is between 60 and 70, add 1 EC2 instance. If it is between 70 and 80, add 2. 80 in infinity, add 5. That's a step scaling. Make sense?
So this is based on the assumption that it's going to scan for the all instances that are in the.
That's correct.
In the account, in this account.
In this account.
So can we restrict it, because some of them may not be, we may not be using the instances, few of them at all, and some of them may be heavily being used. So is it possible that we can limit those? We'll limit the alarm.
Absolutely. Absolutely. You can create a new CloudWatch alarm specific to those instances. You can absolutely do it. But understand, auto scaling group will only worry about the health check of the instances that it created. If you created some other new EC2 instances, it will not worry about it. It has no clue that they existed. Does that make sense? It will only worry about the EC2 instances that it created it. It's scaled out or scaled up. That's it. Am I making sense? Did I answer your question?
Yeah, yeah.
Okay, so these are different different scaling policies. Kind of expect some questions on these different kinds of scaling policies in the exam.
So for step CPU, right? Does it wait for some time? Like, so it is 60 to 70 added one instance, then will it wait for like 60 minutes? Do we mention any time frame here? Oh, here, 300 seconds to warm up.
Yep.
So after adding one instance, it will wait for 300 seconds and then it will check again. If it is more than that 70, then it will add some more.
You got it.
Okay.
Totally got it. So what we did so far is in isolation. What we did so far is not fun because they're not part of application load balancer. Make sense? So now let's go ahead and create an application load balancer, target group, health. Let's define our health checks. And then let's start create the new auto scaling group. And there I will show you how to use application load balancer. So what auto scaling does is it will not only provision new EC2 instances, it will add them to the application load balancer pool automatically so that they will start serving the traffic. And also for the health checks perspective, you can say that EC2 is not my health check criteria anymore. Rather, I want to depend on ELB, elastic load balancing health checks. So if you specify heartbeat.html to return HTTP status code 200, if that is your criteria for success, then that is what it relies on to define the health of your instance. Meaning, once you rely on elastic load balancer health checks, if you go stop Apache, your auto scaling will know that my ELB told me that this instance is unhealthy. Let me go terminate it and create a brand new one and add it to the application load balancer pool. That's the beauty. That's the real auto scaling. Along with these scaling policies, if you bring ALB into the mix, that is the power. Are you guys with me? Any confusion there?
Venkat, this auto scaling gonna incur any cost? I know if we generate new instance, it definitely will incur cost.
Question.
But it itself gonna incur any
It
cost?
does not. Okay. Auto scaling, creation of auto scaling, creation of launch template, creation of security groups, all of these are free.
Okay.
As a result of that, if it ends up creating any new EC2 instances, those are charged. So what I'm going to do now is I'm going to delete this auto scaling group completely. So observe here what happens in the dashboard. So when an auto scaling group is deleted, your EC2 instances that are created by auto scaling group will also be terminated by auto scaling group. It's just a matter of just keep refreshing. It will terminate them. There you go. It's shutting down, and eventually it will terminate. So now you may be wondering, where is the launch template? See here in the under instances, launch templates is here. So I'll delete even this launch template. Now let's go ahead and create a new launch template. Actually, I could have used the new launch template. Yeah, I could have used, actually, that's fine. Create a new launch template. Let's go ahead and create one more time. Observers. Odd web servers are not a big deal, or even web servers. So Amazon AMI is my web server AMI. This is my AMI. My instance type is T2 micro. It's a free tier eligible. Key pair is batch 3. It's going to be VPC, not EC2 classic. Web servers is a security group that I want to put it. Storage value comes from AMI. I don't need to do anything. Network interfaces, advanced details. I'm not doing anything with the advanced details. And after creating a launch template, I want to create an auto scaling group. With the auto scaling group, I'm going to call this my auto scaling group at web servers. And my launch template, yes, it automatically populated web servers. And take a look at this one, guys. It's a description of, yes, version 1. It's a prod web servers, T2 micro, security group is this, AMI ID, batch 3 is key pair name, click next. Adhere to launch template, my pricing options, whatever I mentioned in the launch template, I said all of them should be on demand. So it will go there. And somebody asked, where did we specify what availability zones? It's in network section, VPC, subnets. If I select just 2A, it will create all the instances in only one availability zone. But is it a good standard? Is it a good practice as an architect? Nope. You want them to be distributed because you do not want to hurt your availability. So choose all the availability zones that are available. There are 3 of them in Ohio. Click next. And then there you go. This is what I wanted to show you. Load balancing, enable load balancing. There you go. Application load balancing. I don't have an application load balancing. Gotcha. So I wanted to go to my EC2. I want to create an application load balancing, application load balancer. Go to load balancer, create load balancer, ALB. Next step, web servers, internet facing, IPv4, HTTP load balancer port 80, availability zone, please pick all of them. And add-on service, I do not need a global accelerator. I don't worry, I understand. Keep the web servers as a security group, and routing, I'm creating a new target group, sure. Next step, web servers target group, next web servers. Target type is an instance, or yes, instance, EC2 instances. They are not IPs or Lambda functions, no, HTTP 80. And what's my health check, guys? Slash, is it heartbeat.html? Is this correct?
Yep.
Traffic port, yes, it's the same port. Healthy threshold is 3. These are our settings that day. Unhealthy threshold is 2. Timeout is 2 seconds. Interval is every 5 seconds. Please check that. Success code is 200. This is how I define my health checks for my ALBs. And there are no EC2 instances at this point. So my target group is empty. That's fine. We are going to set up our auto scaling group to kick off the new instances and add it to the application load balancer. There you go. We got a new load balancer now. Let's go back to this guy here. There you go. Refresh. Next step, web servers. There you go. So my auto scaling group, I'm configuring my auto scaling group to utilize the load balancing. I'm mixing 2 different concepts, load balancing and auto scaling group. That's the beauty there, right? I don't want my EC2 instances to be in isolation. I want newly provisioned EC2 instances to be added to the application load balancer so that they will start serving the traffic. That's my end goal. Health checks, guys. Do you want EC2 health checks? No. I mean, in addition to that, of course, when EC2 is stopped, of course, this is default. If EC2 instance is stopped, then it's going to terminate and create a new one. But in addition to that, I want my ELB health checks. Whatever I defined just now in my application load balancers target group here, these are the health checks I defined. Oops, group details. See, these are my health checks / heartbeat.html. I want these health checks to be utilized. That is what I mean. Meaning, if I go to an EC2 instance without having to stop it, if I go log into SH into one of the EC2 instances and stop Apache or auto scaling, will find out that that instance is unhealthy and it will terminate the instance. It will create a new instance from the launch template, add it to the ALB. Beauty. Health check grace period. How long do you want to wait before you start looking for health checks? Use 30 seconds. I mean, I'm picking 30 seconds because I don't want to wait for 5 minutes. Make sense? My desired capacity. So again, I'm starting with, so I want to swing between 1 and 3, sorry, 1 and 10, but my desired capacity is going to be 3. Oops. So my, minimum is, my minimum is 1, my desired is going to be 3. Okay, so it will start with 3 and then swing between 1 and 10 based on auto scaling policies. Now, since we are advanced, I don't need to use this basic. I'll say target tracking scaling policy. I can say average CPU utilization. If it's 50%, if it's more than 50%. If it's more than 50%, then it will create a new EC2 instance and add it to the load balancer. If it goes to 49, like your thermostat, then it will scale in. Instances need any warm up before including in metric. Yeah, I think 300. No, I don't want to wait for 30 seconds. I really don't want to wait. I do not want any protection. Instance scale in protection, I do not want it. Add notifications, I don't need it. Tags, I don't need it. Review it. Makes sense. Create auto scaling group. I know I just did faster this time because we just did it. So now go to activity and you can take a look at it. There you go. It's something is happening. It find out that your desired capacity is 3, but the current capacity is 0. Then it has to match the desired capacity. There you go. It's doing it. You just keep waiting and go back to swing to your EC2 dashboard. You will see that these instances will be, there you go. It's already, it created 3, distributed nicely 2A, 2B, 2C across 3 availability zones. I want to go to auto scaling group one more time and I want to see the activity one more time. There you go, successful. At this time frame, a user request created an auto scaling group, which I created it, changing the desired capacity from 0 to 3. At this time frame, an instance was started in response to a difference between desired and actual capacity, increasing the capacity from 0 to 3. So that's why it spun up 3 new instances and added to the pool. Wait, we did load balancing just now, right? So let's make sure, let's see if it did anything differently, because these 3 should be part of the application load balancer now. So let's go to target groups. In the target group, let's go and go there, targets. There you go. Did we add these guys to the target? Did we add them manually? When we created the application load balancer and target group, it said that there are no instances out there. So it not only created these EC2 instances and added them to the application load balancer. And now we have a decent scaling policies out there. Okay, target tracking scaling policy. If across these 3 instances, if average CPU utilization goes above 50%, auto scaling will kick in and create a new EC2 instance and add it to the pool. In fact, the script that I gave you in the previous class, if you go ahead and run it across all of them, I would recommend running on all 3 of them. Then you observe what happens. Well, it's the same thing, right? So, well, your new EC2 instance will be created and added there, and then you terminate the script, you stop the script and wait for a few more minutes, and you will see that it will scale in. Does it make sense?
I got a quick question, because you did the load balancer really quickly. So we did not do anything different on the load balancer side, right?
Absolutely nothing. Load
So
balancer.
we just,
the only thing is, we did not have any EC2 instances.
Yeah.
We did not have any EC2 instances by the time we created application load balancer. So we had 0. So the target group was empty. I know I did it probably in less than 40 seconds. Sorry about it. I mean, not really. We did it last time. So if you want me to do it again, we'll do it.
Venkat, sorry,
Yes.
I need to step out. Sorry for that.
No worries, no.
Yeah. Talk to you later. Bye.
Bye. Make sense, guys? Oh, I didn't realize
One
it's
question. Now we defined minimum capacity, desired capacity, and maximum capacity, right?
Yep.
When it will reach the maximum capacity, like, because always it is limiting itself to only desired capacity, right?
Nope. Desired capacity is only starting capacity, actually.
Then how to add more up to the maximum capacity?
Your scaling policies will come into picture, right? So you said if average CPU utilization goes above 50%, keep adding it. That's our scaling policy, right? Let's go check our scaling policies here. See this one here? Target tracking policy. It's enabled as required to maintain CPU utilization at 50. Add or remove capacity units as required. 30 seconds to warm up before including in metric. So what it means is, Ramesh, if you crank up the CPUs across all 3, it will add new servers and it will maintain the average CPU to 50%. So let's say, go ahead.
But suppose the average is lesser than 50, then it will terminate and it can recreate, right?
You got it.
But where is the possibility of creating up to the maximum limit?
Oh, so how many do you have right now? At start, you will always start with the desired capacity, which is 3 instances, right?
Right.
Now you crank up the CPUs for whatever you got so much load across all 3 of them. CPU cranked up to 70% on all of them. Yeah. So it added one more EC2 instance, and your average still is 50%. It's added 5th one. It's still above 50%. It added 6th one, 7th one, 8th one.
Oh.
By adding 9th one, it brought it below about 50%. Then it will leave there.
Oh, I thought once the 3 instances average is lesser than 50, then it will terminate the poor performing instances and recreate.
You are right if it goes below 50. Oh. My point is 50 is a magic number, right?
Okay.
So to start with, right now we have a CPU at about 20%.
Right.
Let's crank up CPU to 80%. So it will add more instances to see, because what did we say? Average CPU utilization across all EC2 instances within the auto scaling group should be 50 is what we are saying, right?
Got it, right, yes.
It will try to balance it. Right. But no matter what happens to the CPU, even maybe all 10 EC2 instances CPUs are cranking up to 80-90%, but still it will not add the 11th one because the maximum is 10. Okay. But it can go all the way down to 2 instances also, even 1 instance, because the minimum is 1. Right. Desired is only the starting.
Right.
It will swing between minimum and maximum based on your scaling policies. It will scale in, scale out, scale in, scale out. And this is only a target tracking policy, tracking scaling policy. But using steps, you can go beyond that. This is a simple like thermostat, exactly like your thermostat.
Right. Yeah. Got it.
Yep.
I have one question.
Okay,
So
go ahead.
you have minimum and desired, right?
Yep.
So, and you start at desired.
You got it.
And then when it will go to minimum, because you're always at desired, right? Even if you scale down also, you will stop at desired. You will not go below desired. Then
No.
what is the use of min?
So if you're using the most simple, and might go back to, if this is your objective, maintain current instance levels at all times, you do not. So what you are telling auto scaling is that, hey, maintain these many numbers all the time. Okay. You do not worry about desired capacity. If you have a minimum and maximum, then it will swing between minimum and maximum. But if you want to say that, hey, maintain this current instance levels at all times, then it will be maintained at the desired capacity. Because your scaling policies are there, right, Manohar?
Yeah. So we suppose you are like we are going for step ones, right? Suppose let us say our scaling policy is a step policy.
Yep.
Okay. And then again, you are giving the range, right? Minimum and maximum. Minimum, you say that I have 1, maximum is 10, and your desired is 3, right?
Sure.
So
It starts with the desired, and then based on the auto scaling policies, it will swing between minimum and maximum.
Yeah, it will never go to minimum. That's what I felt. So that's what, because you are always having a desired. Why a desire? Why the minimum will be there when you have desired, right? Desired, is it same as the one that we say that it is the kind of you want to maintain that desired always?
Exactly.
Right?
So your desired capacity come into picture only in this case. If you want to maintain that all the time, okay, what's your desired capacity?
So desired capacity should be same as your minimum. That's what I felt. It should not. We cannot have another minimum, right?
No, you can because if there is a scale in policy that says that, if my CPU goes below 30% scale in, if I say that, understand here, okay? If I have a scaling policy that says that if my average CPU utilization is below 20% scale in, then it goes below your desired up to the minimum.
Okay, that makes sense.
And if I have I'm making a same point, but in a reverse way. Understand this statement also. If I have an additional scaling policy that says that if average CPU utilization is about 60% or 70%, add additional EC2 instances. It will keep adding until maximum. It will scale out until maximum. It will scale in until minimum. That's what I mean by swing between minimum and maximum based on your scaling policy needs. Based on your scaling policies, if you have a scaling policies to scale in, it will keep terminating based on your scaling policies until it reaches minimum. Does it make sense?
Yeah. So desired is only for starting point.
That's correct.
You mean? Okay.
Suppose, Venkat, if you have conflicting rules, like for both greater than and less than 50, add one kind of instance, does it stop us from creating?
Not really. It will actually look at all of them together.
Okay.
Yep. It will take all the scaling policies and then do an intersection.
Thank you.
Yep. Wonderful, guys. That's about auto scaling groups, and very important concept from the exam and even in real life. Okay. Have a fantastic night, everyone, and we'll leave it at that.
so much, Venkat.
Thank you.
Yep.